Assalamu alaikum. Welcome to my online class. Boys, we know that you are fine and safe in your home, and I hope that you are safe in future, inshallah. So, boys, today I am discuss the chapter number 5, that is state of matter and patient. This is a revision class. So, no more delay. We are going to discuss the topics. For studying the topics, by the end of today's class, you must learn about explain the change of pressure with the change of force and area, determine the expression for pressure at a point in a liquid at rest, explain the upward pressure on submerged body in a liquid. Now you can explain Pascal's law and explain the theory of Archimedes. Boys, first I show you a picture. This is a man. He is swimming in the water, but at in a special condition when this man go inside of the water, uh, then he feel a pressure. You see the picture. The pressure is coming on the surface of this man's body in all sides. So he feels a pressure. We know that the inert pressure and upward pressure is not equal, but he feels some pressure. So what is pressure? You see here, this is the picture for man, and he feels some force by the water on the surface of this man. So if you explain how to pressure, then you can see there two terms is comes here. One is force, feel some force on the surface of his body. So two terms, one is force, another is surface, that is area. We know that any surface have only length and breadth, that is called area. So pressure depends on two quantities, that is force and area, and the relation between force, area and pressure is P is equal to A by A. So the pressure is the force exerted perpendicularly to unit area of a body is called pressure, and the unit of pressure is Pascal, that is force by meter square. So the unit of pressure is Pascal. You see here in another pictures, uh, we see here, to apply the pressure on a hand of a man, in two things we use two things. One is a finger and one is syringe, needle of syringe. Here you see there, the pressure is small, but here the pressure is large. In the equation of pressure, we know that P is equal to F by A. Here the area of the finger is too much larger than the area of the needle of the syringe. So if A is too high, then the pressure is decreased, and if the area is decreased, then the pressure must be increased. So here the pressure is small and here the pressure is too high. So boys, it is very easy. What is pressure? Pressure is nothing, again I can repeat it. Pressure is nothing only for force per unit area, two things. And force per unit area, that means force force is nothing but is one kind of weight. F is equal to ma, you know that F is equal to ma, and weight W is equal to mg. So weight and force is nothing, is a similar thing. Now we calculate a math. You see here the example number 1. A cubic of wood exert a pressure of 1.24 Pascal when it is placed on a floor. The force applied to the floor is 9.3 Newton. 9.3 Newton. Calculate the surface area of the cube which is in contact with the floor. So for calculating the area of the cube, and the given that pressure and applied force. So three things: pressure is equal to force per area. Okay, so area is equal to force per pressure. So when we put these values in the equation, we easily get the result. So area is equal to 7.5 meter square. So boys, when you calculate the math, you must be calculated how many things you have to find out uh, the necessary quantities. Here, find out quantities is area, and given that the pressure and force, so three things, and we know that the three things stand in the equation of pressure. So pressure is the right equation to calculating the math. So it is very essential when you calculate any kind of math, you first fixed your target, what we find out at the last, then what are given. Okay boys, thank you. Next, we discuss the variation of pressure with depth in a fluid. You see a picture. In these vessels there are some waters, and we know that it's a one kind of liquids, and liquids have no shape, but when uh, it stand at any vessel, it takes the shape of this vessel, and it have only for weight, that is W is equal to m into g. We already know that, and the weight is always getting on the surface of the bottom line of the vessels. And if we take a consideration, A is the area of these vessels. So, so this weight must be acting a force on the whole area of the vessels. If the height of the water column on this vessel is h, then volume is ah. So in volume of ah vessels, weight is W, that is m into g. We calculate pressure. So we know that pressure is equal to F by A, but here F is missing. But again we know that force and weight is the same thing. So now we calculate the weight. So weight W is equal to m into z, but it is very difficult to calculate the mass of the water. So now we convert this into the density. Density rho is equal to m by v, then m is equal to rho into v, we put here, and g, and v is ah, so w is equal to rho ah into g. Now we put the values of the main equation of pressure. P is equal to F by A, W by A, that is rho A Hg by A. Then we got finally a equation, P is equal to H rho Z. So this is the pressure with the depth in a fluid. You must concern about how to find out the weight of this water. If here give the mass, it is very easy to calculate. If here give density, then you convert in the equation of density. If here give volume, then it is very easy. If it is missing, then must be there some area and height. So you can use this area and height. So first you look what things given in the theorem, then you can convert it and calculated the pressure. In this picture, you see there, here something is large, but here something is less. But when both things are placed on both sides, then it is balanced. Why it's happened? You know that it's had some weight, it's also have some weight. This weight is always time creating on the center of the earth, in the center of the earth. If it is a equal, that means W and this W is always time equal. So if we consider this is a W1 and this is a W2, then W1 is equal to W2. That means W is equal to W. But it is large, it is small. It's all nothing but only depend on density. Density is nothing. The mass per unit volume of a substance is called density. Rho is equal to m by v, and the unit of density is equal to kg per meter cube. It's very easy. Now we explain the upward pressure on submerged body in a liquid. Boys, you see here, we take a vessels and we also taken some waters, and this is a body which is stay inside the water. This is an special condition. It is very difficult to stay this object in this position, but for the calculating on the pressure in a special condition, we take a consideration a particle stray at that position. It is not on the upper of the water, not stray at the bottom of the vessel. It's at not upper, not bottom position. It is just like inside of a water. But you must taken it as a consideration condition. So if we think that this is a special condition, then the upper force and lower force must be creating. If this body stay that position, that means it is a static condition, then F1 is always time equal to F2. But at any moment, if F2 is greater than the F1, then the body is going to upward, and in the opposite sense, when F1 is greater than F2, then the body goes to inside of the water. So it's depend on the bodies and the nature of the fluids. It's going to upward or going to inward. For any situation, there are two kind of force must be present, that is F1 and F2. If you see anybody at the surface of the water, you must be calculate that F2 is greater than F1, and this condition F1 is equal to 0 and F2 have some values. And if you see anybody in spray at the bottom of the vessels, then you must be think that F1 is greater than and F2 is 0. In this situation, this body stay on that condition. But when we calculate both F1 and F2, you must be think this body stay at inside of the liquid. So we take a imagination condition. Now you see here the area of the particle is A. This is a cylindrical shape, so both sides area is equal. The density of the liquid is rho, and the height from the surface of the surface on the upper side of the body is h1, and the height from the surface of the lower portion of the body is h2. But you must see here, when you calculate the height, it must be taken from the surface of the water. You see here, and previously we also find out the force, that's weight. Previously we find out there is weight h rho z into a. So in F1, you only change the height of h1, then the equation is h1 rho za, and F2 h2 rho za. So when we calculate any kind of force, firstly we find out F1, and secondly we find out F2. Then we see what is the ultimately find out, and what the ultimately condition of the fluid. If the body go inside or if the body go outside, this condition you can fill up or calculate in the next way. In this situation, we see that F2 is greater than F1. That means when we observe the picture, we see that the body is going to upward. In this sense, we consider that F2 is greater than and F1 is less. So if we find out the net force, then F net equals to F2 minus F1. So in this way, you can easily find out the pressure, and when you find out the pressure, then you can easily calculate the pressure. Firstly, you can find out the force, then secondly you can calculate the pressure. So firstly, boys, you always time memorize that in this chapters you firstly calculate the pressure, then it put in the firstly calculating the pressure, uh, you must find out firstly force, then you put in the equation of pressure, then it is very easy to calculate. Then we discuss about explain Pascal's law. Pascal's law. You see here, this is a pictures, Pascal's law pictures. This is the example of Pascal's law picture. Pascal's law, boys, you must be memorized the Pascal's law. Pascal's law is if pressure is applied on a liquid or a gas enclosed, this is very important, enclosed in a container. There is an enclosed fluid in a container. You see here, this is a enclosed cylinder. There is a big cylinder. This is a small cylinder. The area is A1 and this area is A2, and A1 is very less than A2. That is 10 times greater than A1. So enclosed container is very important from outside. Then its pressure is transmitted equally. So when you give pressure on this cylinder, this pressure is equally transmitted to this cylinder. There's pressure transmitted equally. So the pressure of this original cylinder or a small cylinder is equal to the pressure of the second cylinder or bigger cylinder. So we know that the pressure of this small cylinder P1 is equal to F1 by A1, and the bigger cylinder's pressure P2 is equal to F2 by A2. So from the principle of Pascal's law, F1 and F2 is not equal, but the principle of Pascal's law, P1 is always time P2. So, and it's also act perpendicularly on the surface of the containers that contact with the liquid or gas. So Pascal's law is very much important in liquid and gas. So boys, two things you must be memorized. The Pascal's law is always time equals for a small and greater cylinders, and the pressure is same, and this law is applicable on liquid and gas. So you see here, if the area is 10 times greater, the force will be 10 times greater from the original force. So it is very easy to calculate force. If you see only the area is how many times greater from the initial area, then you can easily say that force how many times greater from the initial force. So this from the Pascal's law, and if we put the values of P1 and P2 in the Pascal's principle, that is P1 is equal to P2, we find out F1 by A1 is equal to F2 by F2 A2. So this is very easy. Now we're going to Archimedes principle. Archimedes principle. Firstly, Archimedes principle is if a body is immersed in a liquid, the weight of the body is reduced. You see this picture. If any body is immersed or go inside of the liquid, its weight is reduced. In the another word, we say that it lost some weight, because if we know that in these pictures the weight is 5 kg, there is mass is 5 kg, and here the weight is 3 kg, so lost weight is 2 kg. In the same time, when this body go inside, some of water comes to this small pots, and if we take the weight of this amount of waters that comes from the main container. When the body go inside of the water, the weight of the water is equal that the weight lost by the body. So Archimedes give a law: if a body is immersed in a liquid, the weight of the body is reduced by the amount of the equal to displace of the liquid. So how much liquid displaced by the body, its weight is equal the loss weight by the body. So this is very simple Archimedes law. If you see the picture and uh, gauge the knowledge in yourself, if you increase the thinking ability in yourself, you can easily find out what is Archimedes principle. So in this way I can finish my today's class, and I think that you are, again I think that you are safe in your home, and you must be study so sincerely. And for the last, I give a work for you. We calculate the mass of water in a large reservoir. We will now consider the pressure and force acting on the dam. There is contain some water. The dam is 500-meter wide, and the water is 80-meter deep at the dam. You must be calculate what is the average pressure on the dam due to the water, number one, and number two, calculate the force exerted against the dam and compare it with the weight of the dam. Boys, I request you to do this math in your home, and with this hope I conclude my class. Thank you all.